Hello everyone, and welcome to the final part in this six-part series surrounding research methodology. This is a Re-Phew consulting workshop on quantitative research. Today I'm going to talk a little bit about the overview and give an overview of research methodology and the um, uh, workshop this workshop has several objectives, and hopefully by the end of the this particular workshop um, uh, you'll be able to uh, understand again an appropriate understanding and knowledge base around quantitative methodology from different perspectives. So there's in this context, the workshop here is to provide an understanding and basis of quantitative methodology, understand the process of constructing a good quantitative methodological research or methodology, and to acknowledge the main features in quantitative research. So to begin with, I'm going to provide an overview of what, in context related to quantitative research, what statistics is. Normally, when people sort of get into quantitative research methodology and quantitative research, generally speaking, it can throw people off quite a lot because of how intimidating um, quantitative research or methodology can be because of working with numbers, etc. So from a basis point, statistics has two main divisions. There's descriptive statistics, and there's something referred to as inferential statistics. Now, descriptive statistics includes collecting data collection, organizing that data that's been collected, summarizing that data that's been collected, and presenting that data that's been collected. Generally speaking, descriptive statistics, when looking at quantitative research methodology as a basis, descriptive statistics is something is one focus on an area in quantitative research that pretty much anyone and everyone can get into, based on a discipline or a specialty that they're looking to investigate from a numerical focus or a standpoint that relates to understanding a a topic from getting a sort of an overview through data collection. And then there's inferential statistics, which includes making inferences, hypothesis testing, determining relationships, and making predictions. Um, in this workshop, I'm not going to delve into the depth of this too much. I'm going to just give an overview, and in some context, this also means just giving some definitions of different terminologies between in and around different areas around quantitative methodology in regard to descriptive statistics and inferential statistics. Okay, so on that very point, some basic vocabulary around statistics, and generally the vocabulary that I'm gonna refer to here, or the terminologies on this particular slide, our focus is around statistics that actually uh, um, every every quantitative researcher, everyone who's doing quantitative research, will find this context, these terminologies pretty much everywhere in appropriate literature, published literature around specific areas of research, but also in textbooks that provide an overview of the subject. So first and foremost, there's population, which means or refers to in quantitative research and methodology. It is a population is what consists of all the items or individuals about which you want to draw a conclusion. Pretty straightforward, hopefully. A sample is the portion of a population selected for the analysis, and a parameter is a numerical measure that describes a characteristic of a population or collectively characterizes populations. And then there's last but not least, at least on this slide, there's the vocabulary around the terminology statistic itself. So a statistic is a numerical measure that describes a characteristic of a sample used to estimate parameters and give mathematical characteristics of populations. Okay, so now I'm going to just highlight a little bit around sources of data or around data collection. So in this slide, I'm going to highlight a little bit around primary sources and secondary sources. So primary sources relate to the data where the data collector or the investigator or the researcher is in one way or another is using primary sources to collect data for analysis. So this could be from data from a political survey. It could be data collected from a laboratory investigation or an experiment. It can be data or from an observed perspective in some way or another, and generally the research investigator is looking to analyze that data to draw conclusions following some analysis, implementing some analysis. Now the secondary sources is where an investigator or researcher is where they're performing data analysis, but at the same time they're not the primary individuals or researchers or investigators who have collected the data first and foremost. So in this context, the definition is where it could be, for example, where the investigator or the researcher is analyzing census data. It could be where data is being examined from journals or articles, or it could be from where data is being examined from works that are published in the public domain through, for example, context around analytics that have been published by organizations or companies, for example, and that may well be available on the internet and again the public domain. So the next slide here, I'm going to just provide an overview on the data types, and I mentioned a little bit about primary and secondary data sources. Now data types refer to contexts where different data types demand discrete treatment, so it's important to be able to distinguish different variables. And so this means, for example, cause and effect, dependent or independent, and also measurement scales, so nominal, ordinal, interval, and ratio. In this way, these data types are important, and they help not just distinguish between variables, but also can help the researcher and investigator to understand different associations relating to a research topic from different perspectives. So as long as for example, data that is being collected is going to be linked and should be linked to an overall set of aims or objectives. And on this point, I'm now going to highlight some definitions around dependent and independent variables. So, independent variable is in a roundabout way is investigating a causal effect. So, what an investigator or researcher is doing, investigator or researcher is doing, is varying variables in some way to see or understand whether there is a significant change in the dependent variable. So, for example, gender, age groups, class groups, area of residence, for example. So, in some ways, independent variables kind of delve into or link into where investigators and researchers have done, for example, when there's in context of, for example, healthcare research, it relates more to an area or a focus around population health, population research as well. Now, there's also the dependent variable. So this is basically where an investigator or researcher is trying to explain, for example, a newspaper or journal article readership, smoking behavior, drug use, or fear of crime, for example. And this is also a behavior that is being investigated to be measured and usually expressed as a frequency. So in related to frequency, it's about understanding where researchers are investigating the times of number of times an event has occurred in and around collecting quantitative data collection. And often where frequency is concerned, it can be graphically represented in for example a bar graph or a histogram plot. I'm now going to highlight a little bit more around. So I talked a little bit around dependent and independent variables, but on this slide, I'm going to look at that same sort of entity, but look at it from that from a schematic point of view. So, for example, in this slide, there's an overview of the types of variables from looking at data, and where data has two different divisions. There's categorical and there's numerical, and under numerical there's discrete and continuous. Now with categorical you have for example defined categories. In numerical and under discrete, for example, you have counted items, and then under numerical again and under continuous you have measured characteristics. So in this context, what investigators and researchers who are doing quantitative research are looking to understand the data from these two divisions to make their overall predictions, conclusions, and summaries. So in this context, again, I didn't want to delve into this subject too much, but just to say, suffice to say that when looking at developing, for example, a questionnaire or a survey, for example, it's important that investigators and research look at how they want to, for example, uh, um, uh, um, put an over have the data that is collected in a way that they can make good overall perspectives on a particular subject or a research question when and after having collected data. On this slide, I'm just going to delve into a bit more about variables again. Just adding here, I just want to add. I'm just adding a few more aspects in relating to the different types of variables. Again, I mentioned independent and dependent variables, and I mentioned where I've mentioned categorical and numerical, for example. Here I want to just give a bit more understanding relating these. So you have nominal variables, so that could be where there are the definition of nominal variable is where item in a questionnaire, in a survey, for example, when collecting data, it doesn't necessarily have sort of a value attached to it, attached to that per se. It's basically where within a questionnaire the variable has been put there so that those who are participating to complete a questionnaire, they can understand what what the questionnaire or the survey is to do with. So, for example, if it's to do with an area of population health, there may be specific nominal variables which relate to the names of things. So, for example, if it's to do with, again, in an area of population health, for example, if it's relating to, population health or healthcare, for example, nominal variables can be, for example, organ specialties. So, for example, could be heart, could be kidney, could be lungs, could be liver. So basically just names within and part of a questionnaire. And then there's categorical variables, which I've mentioned a little bit in the previous slide, but generally categorical variables have values that can only be placed into categories such as yes or no, for example. Then there's numerical values, which I mentioned a little bit in the previous slide, but generally speaking, these are variables that have values that represent quantities. And then there's ordinal variables, and they also have a value, and they relate to, for example, in a survey or questionnaire, where an investigator wants to understand from an epidemiological point of view, or around demography, or from an an overview around epidemiological perspective. For example, in a questionnaire or survey, are they people who are completing the surveys, are they poor? Are they very poor? Are they fair? Are they good? Are they are they excellent or whatever. So it's basically having ordinal variables in relating to ranking ranking and ordinal. So the word the terminology ordinal, when looking at ordinal, um, those who um, are checking out this Re-Phew consulting workshop at their own leisure, um, relate ordinal variables, ordinal to, for example, the terminology ordering, or ranking. Then there's a terminology around quantity variable, which relates to where investigators and researchers again might be looking to understand, after implementing a survey or questionnaire to collect data, they may want to understand the subject entity from not just from sort of a categorical or numerical perspectives, for example, but from a quantity perspective. For example, it can be relating to salaries or income or price. It can be discrete, can be continuous, number of children in a family, it could be height related, and it could be both. It could imply counting, but in different ways. So there could be ordinal, again, could be all aspects that relate to ordinal variables as well, and also helps investigators and researchers, once analysis is done, for example, it can be used or the data can be used to make their sort of summaries and conclusions as well. Generally, quantity variable help produce data that must that should and must be handled with confidence. So now I'm going to just talk a little bit about levels of measurement, and generally speaking, in this slide, there's a basic illustration here. So where you have, for example, categorical variables and then categories. So for example, whether individuals or research team or who research team or participants who the investigator or researcher is looking to have complete surveys, or for example, the question might be whether, for example, a participant owns a personal computer, whether they have ownership of that, and the category under that, for example, may request the participants to say just yes or no to those particular variables. And then there's internet provider as a category variable, for example, and the categories could be basically the names of the actual internet provider. So so in this example, there's BT for British Telecom, there's Microsoft Network, there's and obviously I'm not going to delve into the categories, but it requests generally participants to just provide almost like a tick box answer to the question. A nominal, and related to this also, levels of measurement, a nominal scale classifies data into distinct categories, wherein there is no implied ranking. So for example, there may be some context around gender, age, etc. But no ranking is actually no order. So no ordering is implied as part of a nominal scale. So then on this slide, I'm going to give an overview of um, of a sort of an ordinal scale, which classifies data into distinct categories in which and wherein ordered is implied, and then when numbers or the ordering is assigned to each category, so that it can be compared, and a member of a category is or a higher category is said to have more of an attribute than one in a lower category. Or so, for example, class ordering or class in relating to class achievement, for example, in and around particular areas of studies, or for example. And then there's intervals, which are not necessarily equal. In this slide, there's this overview where you have a categorical variable and then you have ordered categories. I won't go through the whole sort of the example here. But for example, you can have, as a categorical variable, you can have student class designation, and then you can have ordered categories. You could be, for example, first year, second year, final year. Then there could be, for example, faculty, for example, faculty rank or faculty order under a categorical variable, and this could be, for example, professor, principal, lecturer, senior or senior lecturer, etc. So generally, where you have levels of measurement, there's a categorical variable, which is when investigators or researchers are looking to have questionnaires completed. For example, a categorical variable is what starts off the participant to actually to start the participant who's completing the questionnaire, for example, to then have that linked with a particular ordered category. I'm now just going to give an overview of interval and ratio scales. So a couple of definitions here. So interval is where it shows ordering or of events or objects that are that have equal intervals between a set of numbers. It is an ordered measure or scale in which the difference between measurements is a meaningful or should have a meaningful quantity, but the measurements do not have a true 0 point. So, for example, you have temperature in degrees in Celsius, in degrees Celsius or Fahrenheit, and the level of measurement would be an interval, or there's a standardized exam score, for example, and that the level of measurement would also be an interval. Then there's ratio, which relates to ordering of events or objects on scale on as part of a measure with equal intervals, and where there is absolute zeros, and highest level of measurement around ratio usually are only achieved in areas of particular areas of sciences. For example, to gain an understanding around height, weight, blood pressure, and things like that. So, for example, in this slide, there's height, which is in inches or centimeters. It can relate to the level of measurement would be a ratio. Weight in pounds or kilograms, again, could be a ratio. Age in years or days can be a ratio. And then salary, for example, as well, can be in a ratio. Yes, there is some additional information I wanna highlight here. So according to some researchers, retrospectively, in a while ago, in 2000, they highlighted that um, the interval and ratio scales often are used interchangeably, and sometimes incorrectly. Um, interval ordered categories are no inherent concept of zero, and with that in mind, the interval and ratio scales can be calculated in a meaningful way to understand the differences between categories. So in um, in in some research, for example, research that's done outside of, for example, healthcare research, there are papers that have published some more in-depth understanding, and I will provide some resources at the end of this workshop. But generally speaking, interval and ratio scales are where you have a numerical value, a numerical variable, and there's a level of measurement that can be worked out or investigated to understand relationship or associations. Um, Now, on the next slide here, I'm just going to provide definitions of population and sample. So, a population is a measure when looking at population, or definition around population, is relates to measures used to describe the population, and when using definitions to describe a population, they can be referred to as parameters in some contexts. And then with sample, there is data that has been analyzed, for example, and once data is collected, um, normally those who have so those investigators or researchers who've done quantitative research, when as part of their day to day, and it's part of their careers, for example, normally refer sample as statistics. So in some regard, the terminologies are synonymous. So when researchers say sample, especially researchers who do quantitative research refer sample, when they're talking about sample, what they really mean to say is statistics. And in this illustration, for example, it's just there's a number of people sort of some basic as a basic picture or a pictogram which highlights lots of different people, and some of those people are colored in red. Now, out of that, what statistics or statisticians do look to understand whether that sample, for example, those who are highlighted in color, are representative in a whole population and according to a particular research question, for example. I'm now going to just give an overview of a sample with a bit more understanding. So a sample is generally the way a sample is drawn determines to what extent investigators and researchers can generalize from the findings. So sort of highlighting what was in the previous slide. And a sample can be used to provide an accurate representation of the whole population. But in order to do this, in order for investigators and researchers to do this from a numerical standpoint, for example, they have to be confident that the way that the data has been collected is representative. It can be representative across a particular population, for example. If not, then the research is limited to the sample studied. So I just wanted to provide that perspective in this slide. So we're halfway through this workshop, and I want to provide a bit more of an overview on the types of sampling procedures. So the types of sampling procedures can be divided into divided into non-random sampling, and there's random sampling as well. So non-random sampling relates to provides is where investigators and researchers provide a sort of weak basis of generalization. So generally speaking, once the data has been collected around a particular research question, for example, there's a weak basis to generalize the sort of the data collection from a representative representation standpoint. And in this context as well, there's something that's referred to as accidental sampling, which is where using what is using what is immediately available in relating to the data that's been collected. The researcher does not know in what way that data in the first instance could be biased, and study in the investigation or around a particular research a survey, for example, of data collection. The study could be limited to those who are who are studied. There's also something known as accidental quota sampling, and that's basically where it's having a set quota for each characteristic or group. And the reason why it's accidental is because, generally speaking, when looking to collect data, every investigator, researcher, no matter what the research question is, generally speaking, in the beginning, researchers look to maximize on the data collection process. And generally speaking, so for example, if a researcher investigator is looking to get looking to investigate around a particular research question or a topic, then what happens is that, let's say for example, over 6 months to a year or 2 years or more or whatever, for example, they look to get a maximum a number of responses around that particular question, a research question, and that's the data collection processes. But at the time, they haven't implemented a cap on the data. So what happens is, whilst looking to maximize on the data collection, what happens is that they then have to have almost to have a contingency where for example, in a worst case scenario, if they don't get a maximized response, and a maximized response could be down to a number of things, and every researcher or investigator has an idea of a maximized response based on a particular research question, especially in healthcare, generally speaking. But what happens is, if that is not if researchers can't get that response or maximized response, then what happens is that after, let's say for example, after a duration that a survey has been implemented, they're not getting any more, there's no more responses, then generally speaking, the investigator or researcher has to have a quota sampling put in place. So basically, based on the data that is collected at a particular point, they then say that this is the cap. This is the cap or the quota based on a particular set of variables, for example, characteristics or different aspects in and around a part of the data collection process. Then there is something, as part of the non-random sampling, there is something referred to as propositive sampling, which is using own judgment and intuition to select the sample. So a bit like from another perspective, a bit like quota sampling, propositive sampling is basically where, for example, researchers or investigators know full right and quite well, if around particular research questions research questions where there are, for example, sensitive questions, for example, propositive sampling is where investigators or researchers will know that from a particular group or ethnicity or age range or gender, for example, there's going to be only a number of people who will look to answer specific questions around those specific questions. So investigators or researchers would use their own judgment and intuition to select the sample, select the sample, but also bear in mind, this doesn't bear in mind a good quantitative researcher and someone who's implementing methodology can still make their the research around particular a particular focus still representable in one way or another, if and as long as they are saying, they can say that they anticipated that for example, they know that around particular research questions, they know particular groups of people or those from different genders, for example, are not going to complete those questions. So they can still make it representative, because they know that those in those genders or age groups or ethnicities, for example, are not going to complete any more of those questions, for example. Then there's something called systematic matching sampling, which basically is where researchers look to ensure that when developing when developing or having data that's collected, is ensuring that that throughout the survey or the questionnaire, that there's a systematic approach when providing an overview of the subject in such a way that it matches to what is out what has been documented in literature as well. I will highlight again towards the end of this workshop a bit more some resources that people can that people can check out at their own time. Now, a little bit about random sampling. It's where investigators or researchers look to ensure that sample is drawn is drawn and is representative of a population. There's something also referred to as simple random sampling, which is basically the ideal method or procedure for drawing different examples or different samples. Then there's systematic sampling, which is where there's a selection of every a point of data or a number within a data set at every specific sort of data point in a data set or a list that for example, if a number of points in a data set are selected, systematic sampling allows in some ways researchers to kind of make some predictions and in some way make some sort of early assumptions about the data set that they've analyzed. Random sampling also is in some way random sampling, sorry, also has a point where researchers and investigators look to stratify their data, and the terminology here is stratified random sampling, and it's a bit like quota sampling, but under this sort of category is where stratify that data once data has been collected or there's enough data that has been collected, researchers can sort of put sort of a cap across different points of data in a whole data set, for example. And there's also something called cluster sampling, which is where several stages of where there are several stages of random selections, and population is divided. The population in a data set is divided into segments to actually provide sort of perspectives across different populations, if you like. just a few points on sample size. There's definitions around what's referred to as homogeneous, which means um, uh, where across a data set uh, where they can have it can be uh, representative across a data set and uh, also can relate the content the findings where they can have a small or can be even in a even in a small sample in some ways um, and the sample size um, uh, is something where investigators and researchers have to have to consider as highly as something that is highly variable because um, there's lots of statistics that have to be or can be or should be applied when collecting data. Um, when collecting data, and then with sample size as well, is being able to reflect on across a population in relating to areas of a research question, and then something that all researchers have to take into consideration is that the more questions that are formed as part of um, a sort of questionnaire as part of questionnaire implementation, then they may have to implement more controls as well because generally speaking, more variables can come out, can be formulated or part of the research question as well. So more questions generally will require more controls. So two basic rules about sample size as well. So about 30 or estimated 30 individuals are required in order to provide a pool large enough for even simple kinds of analysis, and that could be descriptive. It could be descriptive or and definitely descriptive and definitely inferential. Um, and Another point here is that you need a sample large enough to ensure that it is theoretically possible for each cell in a data set or in a data set or an analytical table, for example, to have five cases fall in it. So for example, if there's a data set that has a minimum, let's say, of 30 individuals to make an overview of data analysis, then within that 30, have to five cases within that 30, generally speaking, and this is a general assumption that then investigators can say that in an appropriate analytical way that the data set has and does allow some representation, but again potentially just limited to the investigation that has been conducted. I'm now just going to provide an overview definition of normal distribution. So normal distribution is a theoretical concept and is where data groups themselves at a midpoint in a distribution closely approximating the normal curve. So if you imagine a bell-shaped curve, generally the normal distribution is that point in the middle, and generally speaking, the more data points there are that at least retrospectively informing that the more data points there are in the middle of the bell-shaped curve, then generally that can be representative of the whole population in a given analytical or data set. So generally speaking, in quantitative research, normal distribution is sort of everyday sort of language, and it's a theoretical concept. As part of this workshop, I wanted also to provide an overview of skewness. So skewness is where there can be data that does not necessarily follow a normal curve, or may not fall within the normal distribution. So there can be something that refers so skewness can be where there's positive skew equals a low range, and there's negative skews that equals a high range. Again, I will highlight a few resources at the end of this workshop, where those checking out the workshop can look at refer to in their own time. I also want to provide a quick sort of quick definition around variability or dispersion. So variability or dispersion relates to the spread of data. So it's almost where, for example, if you have a data set, if you imagine a data set, a data has been collected, and let's say, for example, the data set has a normal distribution, generally speaking. At the same time, the variability or dispersion can also be identified, and it relates to how well that normal distribution is spread, basically. And what variability or dispersion also allows, it helps investigators or researchers, as far as quantitative data collection or research is concerned. It can enable investigators to evaluate the homogeneity or heterogeneity of data. So that means basically where the data, for example, is homogeneous or heterogeneous across a data set. So how normal, or how much of the how data across a set of data points, for example, are similar, or how they can be different. So the variability or dispersion, again, investigators from a quantitative research perspective look to understand variability or dispersion to make an overview, or get an overview of a particular subjects or subject matter, and see if those can be representative. So I'm going to provide just a few points on what's referred as standard deviation. So quantitative researchers can apply different statistical methods to understand, apart from variability and dispersion of data, they can, after collecting data and applying specific statistics, um, statistical analytical methods, they can make they can make sort of projections, but in order to make projections, there also has to be an understanding of an understanding of standard deviation. Standard deviation is where there's most is one of the most frequently used of measures in relating to variability, and in this context, standard deviation is an average deviation of scores from a mean, and generally standard deviation, once data has been collected and analyzed, standard deviation allows researchers and investigators to determine what's referred to as confidence intervals. And I won't go into that too much, but again, I will highlight a few resources towards the end of this workshop that can be referred to at your own times. So I'm now just going to highlight a little bit about a range, which is basically the most unstable measure of variability, and what researchers and investigators do to sort of understand range or determine the range. It also is where investigators look uh, to understand how to understand to what extent are the variables related, and then also a difference between the highest and lowest scores in a given data set, in a given data set, and also the range is always reported with other measures of variability. So in one of the beginning slides in this workshop, I highlighted some context between dependent and independent variables. The range can help researchers and investigators to use use or apply a particular range so that they can determine measures of dispersion and variability, and also to determine whether that range is or can be applied across a data set. For example, if the same investigation is conducted again, applying a different set of variables, for example. So in quantitative research, the range, again, as I mentioned, is an unstable measure of variability, because within it, it can have potentially quite a few or lots of confounding aspects that are linked to it, that are linked as well. Okay, so the next few slides as part of this Re-Phew consulting workshop will relate to inferential statistics. So some basic points to begin with around inferential statistics. Inferential statistics generally is where statistics are combined with mathematical processes and logic that allow researchers and investigators to test hypothesis about in healthcare, which is in aspects of healthcare or healthcare research, which can be the most it can be the most intimidating, but also the most sort of rewarding areas of healthcare in relating to making making overall sort of projections around a particular research questions. For example, where they test hypothesis using data obtained from either probability or non-probability samples. Then can be used, inferential statistics can be used to make inferences or judgments about larger populations based on the data collected from a smaller sample. So for example, in part of the data collection processes, if an investigator or researcher hasn't been able to collect a large enough sample across a particular data for as part of that data set, for example, then in a way it can cause problems in making inferences. But if particular statistics are applied to a data set, then it can allow researchers or investigators to make inferences even on a smaller sample and drawn from a whole population. So an example for in this context, it could also be exit polling used during elections to determine how the population of voters voted, let's say, for example. And a key component of inferential statistics is the calculation of statistical significance of a research finding as part of aims or objectives around a particular research question. Inferential statistics also can be used to determine whether changes in a dependent variable are caused by an independent variable. So inferential statistics can get quite in depth quite quickly, and so generally speaking, it is why when testing out particular areas of a research question, researchers, even the most experienced researchers or investigators doing quantitative research may decide they want to do simple descriptive statistics to make or draw conclusions about a particular subject entity or a research question. Inferential statistics also allow researchers to assess ability to, again, draw conclusions that extend beyond the immediate data. So, for example, if a sample represents the population, if there are differences between two or more groups, if there are changes over time, or if there is a relationship between two or more variables. So in this slide on inferential statistics, I've highlighted with a small illustration here that, for example, two main sort of two main sort of definitions to recall on in relating to inferential statistics relates to estimation and hypothesis testing. So for example, with estimation, it could be relating to estimating the population mean age in relating to making a research sort of more representative by involving those who may be sort of part of hard to reach groups or population, including ages, might be part of, or should be part of, every quantitative researcher's aim and objective, to involve sort of the demography around sort of the mean age across across age groups. And then there's hypothesis testing, which is where there's a test testing a claim against a particular parameter. So again, could be could be around age. For example, it could be around a height. It could be around I don't know, for example, hair color. It could be against anything really. Generally, inferential statistics, where estimation and hypothesis testing is concerned, is allowing quantitative researchers and investigators to draw conclusions, and make decisions concerning a population-based perspective on a sample or set of results that have been collected through quantitative research. So we're nearly at the end of this workshop now. Just a few more slides and then we'll be done. So hypothesis testing, just to give a few points on this, a few overview points about hypothesis testing. So one of the main things here is how much of this effect is a result of chance, and quantitative researchers, at least those who are sort of hardcore quantitative researchers, will have hypothesis testing as part of their sort of routine practice in relating to understanding chance results, or chance or whether there are whether sort of more informed inferences can be made, and then also how strongly are the two variables or more variables associated with each other. So hypothesis testing allows these two main points to be determined through inferential statistics. Okay, so this is the final slide on this workshop relating quantitative methodology, and this is an overview on selecting the right statistical test. So selecting the right the right statistical test relies on knowing or understanding the nature of your variables. So again, in the beginning of this particular workshop, I highlighted some points related to independent and dependent variables. So it's knowing the nature of the different variables, the scale of measurement and how they can be determined, the distribution and shape, and also the types of question that investigators or researchers want to ask, so that across a data set, once asking that particular question, whether the data the data that's been collected allows the investigator to make inferences across a whole a whole data set, generally speaking. Okay, so that ends this workshop, this Re-Phew consulting workshop on research methodology and quantitative research. Um, and thank you for those who are checking out this workshop. There's a few resources and references that I'm going to highlight here, and there's some that are descriptive, relating to descriptive research. Quantitative methodology, but also some around qualitative research. And it's important to understand that with qualitative research, quantitative perspectives can also be determined in some way. So, for example, help researchers and investigators to see or understand from a quantitative research perspective, to understand if and whether quantitative research can and should be conducted alongside qualitative research. So on purpose, as part of this workshop, this Re-Phew consulting workshop, I've gone ahead and highlighting a few of the resources around that. So there's a resource here by Berdania and Lennart from 2020, and they published a work around. So you have a right. So you have to write a literature review, a guided workbook, a workbook for engineers, and generally literature reviews in pretty much every subject entity have similarities, but this work by Berdania and Lennart is quite a good one. And then there's a works by Blackster and a team from it's a little bit dated, but they're still quite good, in 2006, and they write on works on how to research, and it's a Berkshire Open University Press publication. Then there's works by Hussey and Hussey in 1997, and it's a work relating a publication relating to business research, and it's a London Macmillan publication. There's works by Turabian in 2007, a manual for writers, and it's a works that was published by the University of Chicago Press. There's work by it's a paper publication, a peer review paper publication that highlights, is there a need for healthcare scientists and educational support surrounding chronic kidney disease, or CKD, laboratory investigations and tests. And it's research that summarizes polls through a patient support group platform. It was published in the Turkish Journal of Nephrology, and the authors Mohammed and team in 2020 highlights this work from a descriptive statistics perspective. So it's kind of a good sort of go-to peer review publication to get an overview of how statistics have been applied around an important healthcare question, but also around important and sensitive questions. And then there's work by Wallace and Ray in 2007, where they have a book publication on critical reading and writing for postgraduates, and it's a London Sage publication. There's another publication here by Snyder in 2019, literature review as a research methodology, and that Snyder highlights this particular topic as an overview and guidelines in the Journal of Business Research as a peer review publication. And then finally, from a sort of a hardcore statistics perspective, there's a book publication by Pearson Prentice and Prentice Halling Corporation, and it's a publication titled Statistics for Research, and it was published in 2008. And for most quantitative researchers, or those who are even sort of trying to get an understanding around statistics and how they can be used, quantitative design, for example, Statistics for Research is kind of a go-to publication. So I would encourage to check that out. Check that publication out as well. So there are just a final point. There are quite a few books and publications that can be especially around healthcare, where investigators can use or approach to kind of interact with quantitative research with a bit more finesse, because sometimes sort of when there's research that's published in some ways, in some contexts, it can be quite intimidating. So once there are investigators who are sort of early in their processes and thinking of ideas, for example, looking at peer review publications to kind of gain some inspiration is also something that should be encouraged. So thank you for listening to this workshop, and hopefully the points around quantitative methodology and quantitative methodology and quantitative research can be something that everyone can get into as part of their sort of professional development. So hopefully this has been helpful. Thanks for checking out this workshop, and feel free to check out the other Re-Phew consulting workshops, and feel free to contact at any time if there's any further writing or presentation aspects that you need sort of support with. Okay, thank you.